Hello students, myself Dr. Suman Katiyar. This is our fourth lecture on electroconductance, and today we will cover a new topic which is known as transport number. Transport number is also known as transference number or ion transport number. So it is having three names: transport number, transference number and ion transport number. All the three terms are same. Transport number is represented by small t or T positive. T positive means transport number of cations, same way T negative means transport number of anions. Transport number or transference number. So let's see how we define this transport number. We all know that during the process of electrolysis, the ions present in the solution move towards oppositely charged electrodes. The movement of ions is really responsible for constituting the electric current. Since there is a scientist whose name is Hitov, and he has given a very famous rule. As you all remember that in my previous lecture we have discussed about the Hitov theoretical device about ionic mobility. According to Hitov, both the cations and anions move with unequal speeds. This unequal speed is from where it is coming. Why the cations and anions are moving with an unequal speeds? Let's discuss this. The movement of ions is really responsible for constituting the electric current. Since the electric current is different in different compartments, that is why the ionic mobility is different, or we can say the cations and anions move with unequal speeds. Therefore, the fraction of total current carried by cations and anions will also be different. This gives us the definition of transference number or Hitov number. How we can define it? The fraction of the total current carried by the cations and anions is termed its transport number. This I have told you earlier, that transference number is for cation is represented as Tc, or for anion it is represented as Ta respectively. How we derive it? We all know that suppose UC and UA represent the speed of cations and anions respectively, then UC in equation 1 current carried by anions is proportional to, it is proportional to UA, means speed of anion. If we remove this proportionality, it becomes as K multiplied by UA. Same way, current carried by cations is proportional to its speed UC. If we remove proportionality, it will become K into UA. Total current carried by both ions becomes UA plus UC. Again we remove proportionality, it comes as K multiplied by UA plus UC. If we divide this equation with the equation 1, we will get this equation. Above statement represent transport number of anion. Thus, TA becomes speed of anion divided by total speed of cation and anion. Same way, transport number of cations becomes speed of cation divided by total speed of anion as well as cations. If we just add transport number of cations and anions, we'll see that the value comes 1. You simply see, if we just add Tc plus Ta after solving the equations, we will get what? 1. So Tc plus Ta is equals to 1. Same way we can write this Tc like this also. Tc is equals to 1 minus Ta, or transport number of anion 1 minus Tc, transport number of cation. We all know the speed ratio UC upon UA is given by R. Okay. If the speed ratio is represented by R, then R is equals to speed of cation divided by an anion. This formula, by putting the value of Ta 1 minus Tc, we get a new formula, R, or the speed ratio equals to Tc divided by 1 minus Tc. Same way all these formula we can get, and these formulas we will use in solving the numerical problem. Okay. So remember all these formulas, these are very important. Next comes how we determine the transport number. Okay. For determination of transport number, 2 methods are there, or we can say 3 methods are there. The very first method is hit-off method. Second method is moving boundary method. The third method is not in your syllabus. With the help of EMF also we can calculate transport number, but this method is not in your syllabus. So we will discuss only 2 methods, hit-off method and the moving boundary method. But today I will discuss only the hit-off method and its how we derive it numerically. Okay. We all know that according to hit-off rule, fall in concentration around any electrode is directly proportional to the speed of the ion moving away from it. क्या होता है? Suppose two chambers are there, anode chamber and cathode chamber. We all know anions move towards cathode and cations move towards anode. And when after electrolysis, when the movement of ions takes place, at that time fall in concentration around any electrode is directly proportional to the speed of the ion moving away from it. इसका क्या मतलब हुआ? इसका ये मतलब हुआ कि अगर एनाइंस की स्पीड ज़्यादा होगी तो क्या होगा? जो फॉल इन कंसंट्रेशन एट एनोड है वो ज़्यादा होगा इन कंपैरिजन टू फॉल इन कंसंट्रेशन एट कैथोड. Okay, so fall in concentration of cathode divided by fall in concentration and anode, ये किसके बराबर हो गया? स्पीड ऑफ एनाइन डिवाइडेड बाय स्पीड ऑफ कैटाइन. इसको हम लोग इस तरीके से भी लिख सकते हैं. स्पीड ऑफ कैटाइन एंड एनाइन वी ऑल नो इट इज UA upon UC. इफ़ वी ऐड 1 टू बोथ साइड, अगर हम दोनों साइड 1 को ऐड कर दें तो 1 प्लस फॉल इन कंसंट्रेशन ऑफ कैथोड डिवाइडेड बाय फॉल इन कंसंट्रेशन ऑफ एनोड, ये बराबर हो जाएगा UA डिवाइडेड बाय UC प्लस 1. When we solve it further, we will get this formula. Total fall in concentration around both the electrodes divided by fall in concentration around anode. अगर हम इसका रेसिप्रोकल लेंगे तो क्या हो जाएगा? fall in concentration around anode divided by total fall in concentration around both the electrode. This becomes UC upon UA plus UC. ये किसके बराबर है? दिस इज द ट्रांसपोर्ट नंबर ऑफ कैटाइन. ओके, कैटाइन इज ऑल, इसको हम लोग NC से भी रिप्रेजेंट कर सकते हैं या इसको हम लोग T पॉजिटिव से भी रिप्रेजेंट कर सकते हैं. So thus the transport number of cation can be determined by measuring the fall in concentration around anode and the total amount of electrolyte decomposed in the same time. Now अब ये क्वेश्चन उठता है कि ये वाला स्टेटमेंट कहाँ से आया? हम अकॉर्डिंग टू Faraday's second law, we all know if the same amount of electricity is passed, then the amount of electrolyte decomposed at both of the electrode is equal. If the concentration is expressed in terms of gram equivalent, then the same formula, this formula or this equation changes like this, that Tc becomes number of gram equivalent lost from the anodic compartment divided by number of gram equivalent lost from both of the compartment. Generally हम लोग क्या करते हैं कि how we calculate the loss और fall in concentration and anode, इसको देखने के लिए what we do is a silver coulometer or voltmeter is connected in series and the amount deposited is measured with the decomposition of silver in coulometer. ये स्टेटमेंट हमें कहाँ से मिलता है? दिस स्टेटमेंट वी आर गेटिंग फ्रॉम Faraday's second law. According to Faraday's second law, when the same quantity of electricity flows through the silver or copper voltmeter, the same amount of gram equivalent or silver or copper will be deposited. So this statement is coming from Faraday's second law. इसकी वजह से now it becomes easy to determine the transport number of any ion simply by knowing fall in concentration around anode and the amount of silver deposited in silver voltmeter or copper coulometer. अब सेम फॉर्मूला को हम लोग कैसे सिंप्लीफाई कर सकते हैं? नाउ ट्रांसपोर्ट नंबर ऑफ कैटायन, ये क्या हो गया? दिस बिकम्स नंबर ऑफ ग्राम इक्विवेलेंट लॉस्ट फ्रॉम द एनोडिक कंपार्टमेंट divided by number of gram equivalent deposited in the voltmeter. लेकिन इस फॉर्मूले को प्रूफ करने के लिए और अप्लाई करने के लिए वी हैव टू सी टू केसेस. कौन से केसेस देखते हैं? वी हैव टू चेक दैट विच टाइप ऑफ इलेक्ट्रोड्स वी आर यूजिंग. It is noteworthy that the above result is applied only when the electrodes are not attacked by ions. इसका क्या मतलब हुआ कि we have to take those electrodes which are not attacked by the ions, means electrically neutral electrodes we have to take. कौन से electrodes लेंगे? हम लोग प्लैटिनम का इलेक्ट्रोड लेंगे. अगर इलेक्ट्रोड्स अटैकेबल होंगे, सपोज वी टेक सिल्वर इलेक्ट्रोड्स, देन दिस फॉर्मूला changes, and if the electrodes are attackable, the result is calculated in a different manner. And this formula we know that TA, once we get TC, easily we can obtain TA by using this formula, because TA plus TC equals to 1. So once we calculate TC, then from this formula we calculate transference number of Ni. Next, let's see which factors influence transport number. There are 3 and 4 factors on which the transport number depends. The first factor is the mobility of all the ions present in the electrolytic solution. We all know that aqueous solution of sodium chloride upon electrolysis gives us sodium ions and chloride ions. But it is experimentally it was seen that the mobilities of sodium and chloride ions are different. Okay. Differences in electrical mobility creates difference in transport number. In case of sodium chloride, less than half of the current is carried out by sodium ion and more than half is carried out by the negatively charged chloride ions. Why this happens? Because the chloride ions have higher mobility than the sodium ions. But the sum of the transport numbers for all the ions in solution always remains unity. Next is on the concentration of the ions. Transport number depends on the concentration. The rate of migration of ions is influenced by increasing the concentration of the electrolyte. There is a formula given by Jones and Dole. The variation of transport number with concentration is given by n equals to n naught minus a under root c. इसका क्या मतलब हुआ? It is directly proportional to the root c. यहाँ पे n और no क्या है? These are the transport number of the given ion in a solution of concentration C. Next is effect of temperature. How temperature affect transport number is, the extent of the variation of the transport number with temperature is evident from the data for the cation of a number of chlorides. It appears when we check the cations of chloride, we saw that the rise in temperature tends to gradually bring the two transport number closer to 0.5. और in other words हम कह सकते हैं कि ions tends towards equal speeds at higher concentration. वो 0.5 के आसपास रहना चाहते हैं. Next is hydration of ions. Hydration of ions also affect transport number. How it affects? It tends to decrease the transport number. इलेक्ट्रोलिसिस के टाइम पे क्या होता है? Owing to solvation, क्योंकि हम लोग उसको पानी में डिज़ोल्व करते हैं और हम जानते हैं कि पानी की जो सॉल्वेशन एनर्जी होती है या के होता है वो बहुत ज़्यादा होता है. Owing to solvation, ions not only transport the electric charge but also the solvent in their solvation sheets. वो चार्ज के साथ साथ क्या करता है? थोड़ा सा सॉल्वेंट भी अपने साथ कैरी करता है. For this reason, transport number determined from Hitov method are called as apparent transport numbers, in contrast to true transport number which take into account only the velocities of ions. अगर हम सिर्फ velocity की help से transport number calculate करें तो वो ज़्यादा सही होती है in comparison to the Hitov method of calculating transport number, because in case of Hitov method क्या होता है? Not only the charge but some solvent sheet is also carried along with the ions. One more factor is also there on which the transport number depends. This is a formation of complex ion, और इस complex ion के formation से हमें एक abnormal transport number भी मिलता है, but since it is not in your syllabus, so no need to discuss it here. That's all. This one question I have given, you all solve it and send me the answer of this question in my Google class. Thanks to all of you. This is all about transport number. In my next lecture, we will discuss with the help of Hitov apparatus how we calculate transport number. Thank you. Have a nice day all of you.